Are your video conferencing, e-learning, or gaming applications running slow on your Wi-Fi campus networks? Do you wish that there was something easily you could do about that? It turns out there is. Using a widely supported mechanism of your Wi-Fi access points, you can split the internet traffic in the access point into two queues using DiffServ code points. And if you do that, your access points will give priority to one of the queues, and that's where you place your interactive packets from Zoom, Teams, esports, etc., giving them a much better latency and a much better capacity. But the access point doesn't have the software or the understanding to know what an interactive packet is, or what a Zoom packet or a Teams packet is compared to any other packet. So how does that work? Well, let me show you. So if you have your campus buildings and you have internet coming in here, probably going through a firewall, and then maybe served from multiple providers. From here, it goes into a switch. From the switch, it goes out to different access points in this building, maybe served through another switch to access points in the other buildings, etc. If you have a situation on any of these access points where recreational traffic, like Netflix or someone doing a heavy download or sharing files over peer-to-peer, this RF easily gets congested. And if on that same access point someone is trying to do something important, like a video conferencing, e-learning, maybe they're active in esports, that will have a devastating quality of experience impact on them when they're trying to do what is important. So that's what we're trying to mitigate or to improve. And the way it works is, inside the software of the access point, there is, unless you do anything else, there is a single queue for all the packets, and then out of the queue, it goes to the RF. So it goes over to radio waves. And all the packets will enter that queue. So on RX, or packets received into the queue, stay in the queue, FIFO queue, comes out the other end. Now, what we want to achieve is two queues. It's not that complicated. So some packets that are interactive will enter this queue, and there won't be that much traffic in this queue because interactive traffic will typically be less volume. Whereas bulky or download packets will go into this queue, which will typically have a lot of packets in it. But the access point software, as long as there's any packet in this queue, it will take it first. And only when this queue is empty will it look for packets in this queue before transmitting. This is called strict priority queuing. There are other mechanisms as well. But it's a dual queue setup to make sure that the interactive packets have a much better experience and priority in the RF. If you do that, someone using esports or on video conferencing or any other latency sensitive activity, even web browsing, will have a much better experience. But like I said before, the access point can do the dual queue setup, but it has no way of knowing that Zoom, Teams, or esports are latency sensitive. For that, you have to go to a technology from AppLogicNetworks. But that treatment and that intelligence can sit over here at your internet gateway. So as the esports or Teams packets are coming in, AppLogicNetworks will do a couple of things. It will classify the app. So instead of just having a packet, it will know that this is a Netflix packet, or this is a Zoom packet, or any of the other thousands and thousands of apps that AppLogicNetworks classifies. Then it will have policy, and the policy will say that if the app is interactive, then set the DiffServ code point. I'm just going to say important. There are a couple of different tags that you can use for this, depending on how you've configured the access point. Else, set the DiffServ code point to, let's call it bulky or unimportant. So the packet that then comes out here has the DiffServ code point in the IP header changed, and that packet will then survive across your entire network like this. And as it hits the access point, it could look just at the DiffServ code point in the IP header to determine that the Zoom packet should go here and the Netflix packet should go here. And that will achieve your quality of experience improvement. And that is how using DiffServ, AppLogicNetworks can make your campus Wi-Fi network much better.